Hey guys, welcome back to AlgoYogi. Now we are doing array and hashing series, and our next problem in the list is find pivot index. So let's go to LeetCode. There it is. Given an array of integers called nums, calculate the pivot index of this array. The pivot index is the index where the sum of all the numbers strictly to the left of this index is equal to the sum of all the numbers is strictly to the index's right. So index is not being included in any sum. It's the sum that to the left of index and right to the index that has to be equal, right? So, and even they have explained it right here. If the index is on the left edge, so basically the first index of the array, and then the left sum is going to be 0 because there are no elements to the left. This applies to the right as well. Makes sense. Return the leftmost pivot index if such index exists. Otherwise, you return, -1. So let's go over this. We are trying to find the pivot index. So that can lie in basically, inclusive range of all the indexes here. So let's mark all the indexes 0, 1, 2, 3, 4, 5. So our answer could be any of these values. These are the indexes, right? So what we are really trying to do is find an index. Let's say if this was that index. So if I'm choosing this index as my answer, then the left sum of these values have to be equals to the right sum of these values, right? So this is 11 and this is also 11. So this will be my answer, right? So how do we do that? So let's go to the brute force solution, right? So the brute force solution would be, how about I iterate over all the values. I will go from left to right, visiting all the indexes. So I'll say for I in range length of nums, right? And then I will calculate the left sum. So what is left sum? Left sum would be, I will use this sum, some internal function. So what I'm trying to do is find the sum of the values in nums from where? From 0 till this index. So by the way, I will just put I because this I is exclusive, right? I is exclusive. And for right sum, I will say sum nums from where to where. So I plus 1 because I don't want to include I plus 1 till the end. So you can just leave this empty. I'm talking about Python here. In other languages, you can like find out how you're gonna do that. Or you could use two different small for loops to calculate the first sum, left side sums and right side sums. But remember that you are not including the I, okay? And if this left sum is equals to right sum, then you will basically return this I. Otherwise, our problem said like you can return -1. So you will come out and then say return -1. So this is our brute force solution. This right here is our brute force solution. So what is the time complexity for this? You might see right now, oh, this is like the time complexity right now. It appears to be big of n, but actually it's not. So this is time complexity is actually n square, and the reason is these two right here, they are in itself basically takes the time complexity of big of n, and this right here outer our loop basically makes the time complexity big of n square. And for space, we do not have any space complexity. So that is brute force solution. Can we do better? Yes, of course. This is not optimal. We can do it better in big of n. So how do we do that? Let's clean up our page. All right. So what's a better solution? What would be a better solution? Since it was all about like calculating the left sum and right sum. How about if I have the total of this nums, if I find the total of all the values, sum, and I have left sum initially, which will be 0. So I can calculate this immediately when I'm on like any of these indexes. So initially this is 0, and I will go from left to right, and let's say if I'm right here, I'm standing on this integer, then so far my left sum would be 1, but then because my left sum is right here, my left sum is 1, and I'm standing right here, to find the right sum I can just do so right sum I can just do total minus left sum, right? But to this left sum I will also add the current number. So current number would be nums at I. Okay, so this will give me my right sum. So I can use that this total. That's the reason I introduced this total, to basically calculate it. So let's write the pseudocode. So for I will say I in range length nums. All right, length nums. How do you calculate the right sum? So right sum would be total minus nums I. The reason I'm doing nums I because I don't want to consider it with right sum as well. Left sum so far hasn't included it, but I don't want to basically include it with my right sum as well. So I am subtracting the left sum plus this current number. This will give me my right sum, right? This will give me my right sum. So I can just directly check this, right? I can just check this instead of if right sum equals to left sum. By the way, these two things you can combine them into just one line, right? But I'm just writing it for the sake of clarity. Then you can return basically I, right? Otherwise add that to your left sum. Now you can add that to your left sum plus equals to the current number, because later for next values it will be considered right here. Otherwise you can just return -1, all right, in the end. So this will be this solution right here, brings down the time complexity to big O of n, and there is no space complexity, so it's constant. That is it. All right, so that's our bestest solution. So let's implement it. It's really easy. Let's go back to AlgoYogi, not AlgoYogi, sorry, LeetCode. Awesome. So as I said, total would be sum. That's the inbuilt function in Python. Other languages you can find out. And for left sum, we initially assign 0, and for I in range length nums, I will calculate right sum. So this is what I was saying. So right sum is equals to total minus left sum plus the current number, because you want to exclude it from the right sum as well, right? You don't want to include it in anything. So left sum does not have it added yet, but then right sum also needs to basically subtract it. So ith, and if right sum equals to left sum, then you will return this I, that's the pivot index. Otherwise left sum will just add this value to left sum. So this is nums at I, and if you didn't find it, then you just return -1. All right, so let's zoom out. and test this. Awesome. Let's submit. Great. Time complexity is big of n. That's the best you can achieve here. And space complexity is even better. The bestest constant. All right. And this is what I was saying, that you don't have to have an extra line. You can just check this is the right sum. Just check it right here. You know, in your if, get rid of this, and then you can submit this as well, right? And then finally, this also works. Awesome. So let's go back to AlgoYogi, mark this problem solved. See you guys in the next problem.